Chapter 1 is an overview of PLC or programmable logic controllers. So objectives of this chapter: after completing this chapter, you will be able to define what a programmable logic controller is and list its advantages over relay systems. So we'll compare it to relay systems, okay? Because originally the PLC first came to replace the relay systems, but later on we added on it other different types of applications, different type of functions, and more functions as well. So we'll define what is PLC and advantages of a relay system, identify the main parts of PLC and describe their functions, outline the basic sequence of operation for a PLC, and then at the end identify the general classification of a PLC. So PLC are now the most widely used industrial process control technology, are the most widely used in industry now. What is PLC? PLC is basically a digital computer, okay, designed for use in machine control, designed for use to control machines. It has been designed, so that's the point, it has been designed why? To operate in the industrial environment. Its design purpose is to operate in industrial environment. So you will see that programming it is very easy, so it doesn't really, it's not hard to program it. And that's one thing. Later on you see other advantages, but I'm saying one, which industry like to have something easy to do, fast and easy, but also industry are interested in other stuff as well, so we are not going to talk about now, and is equipped with a special input-output interfaces and a control programming language. Okay. So it's designed to operate in the industrial environment, and it's equipped with special input-output interface and control programming language. A programming language to control the devices, to control basically the output, okay, to control your machine. So now if I ask you what is PLC, you can tell me it's a digital computer, etc. Okay, so you know the answer initially, and this is part of your homework, so you need to answer this question. Initially the PLC was used to replace relay logic. As I was saying, initially was used to replace relay logic, but its ever increasing range of functions includes timing, counting, calculating, comparing, alright, and the processing of analog signals. So increasing the range of functions, you can have even more and more, so they keep increasing and adding to the functionality, because at the end it's a digital computer, so we can try to add on it, make different version, updated version, has more functions. The structure of PLC is based on the same principles as those employed in computer architecture. So identify 4 tasks in addition to relay switching operations that PLC are capable of performing. Originally it was designed to replace relay logic, so then it has the capability of doing a task like relay switching operations, on off as a relay. So switching operation, it has this function, but can you identify other 4 tasks that are able to do in addition to relay switching operation? Alright, so we saw that in previous slide, and this is part of your homework. So PLC advantages. What are the advantages of PLC? Look the figure to the left and the figure to the right. So this is PLC control panel, this is relay control panel. So elimination of much of the hard wiring associated with the conventional relay control circuits. That's one advantage. Increasing reliability. Why? Since all the logic is contained in the PLC's memory, the logic are contained in the PLC's memory, then there is no chance of making a logic wiring error. So that's what we mean by increasing reliability. Another advantage, more flexibility. It's easier to create and change a program in a PLC than to wire and rewire a circuit. That's what we mean by flexibility. It's easy to change the PLC program here, which is inside the memory of the PLC, rather than wiring and rewiring the circuit in case of relay systems. So then it will have advantage of more flexibility. Talking about the cost, generally if an application has more than about a half dozen control relays, like if it has more than about half dozen, dozen is 12, right? So like more than six relays, it will probably be less expensive to install a PLC. So that's a general rule. If you wish, if you think you have 6 relays in your application, so then it will be less expensive to use PLC. Okay, communications capability. This is one advantage. A PLC can communicate with other controllers or computer equipment to perform such functions as supervisory control, supervision, data gathering, monitoring devices and the process parameters, and download and upload of programs. So this communication module in a PLC usually is Ethernet connection. It helps communicate with other PLC and even communicate with the PC in which you are programming. You have a software in which you are programming, and you download your program to the PLC. Download and upload a program, but also supervision control, gathering data, so connecting to the network if you wish. So then this is a communication capability which a PLC has. Faster response time. This is considered also an advantage of PLC, faster response time, and this is critical in industries because machines that process thousands of items per second, and objects that spend only a fraction of a second in front of a sensor, just a fraction of a second in front of a sensor, requires the PLC's quick response capability. So that's required that the PLC has a quick response capability. So it's an advantage of a PLC. Easier to troubleshoot. To find and fix problems, users can display the control program, that's a control program, on a monitor and watch it in real time as it executes. Well, here like you can have like a human machine interface in which you are monitoring what's happening on a real time, and then if suddenly a problem happens or so, you're able to watch it on this human machine interface and try to stop the process, emergency cutoff or whatever, and troubleshoot and maintain, so avoid catastrophic problems. But also you have, as maybe any other controllers, you have the simulation part in which you can do your simulation before implementing it on a process itself. But the PLC has the advantage of monitoring, so this is a human machine interface. So I want you to list 6 distinct advantages that PLCs offer over conventional relay-based control systems. Maybe you can count them, they are maybe 6 or less, then you need to find another one. Okay, so this is also one of your homework. You need to list 6 advantages. What are the parts of a PLC? The major parts of a PLC system are the central processing unit or CPU, the input-output section, the power supply, and the programming device. So here is the CPU, input-output module. That's the input module, that's the output module. Power supply, that's the power supply, and the programming device. So those are basically the major parts of a PLC. You have CPU, you have input output, you have power supply, and you have programming device. Of course, the program goes to the memory, so you need memory for the CPU to do the programming executions and also to save your program and save your data. Yeah, so you need memory, of course. So the term architecture can refer to PLC hardware or PLC software or both. Well, architect, as we saw on the previous page, a general architect of a PLC is CPU, input-output modules, power supply, memory. Well, basically you have this 4 as a major parts, like right, CPU, input-output, power supply, and memory, right? And I forgot programming device. So in an open architect, usually you can replace maybe the input module by a different module from different places, so it's open. Maybe you can replace the CPU, replace the power supply, etc. From a different manufacturers, from different type of manufacturer, from all the available manufacturers you have. So then it gives you like kind of flexibility on changing things, and the architects is all clear. But in closed architects, if assuming the input module it's not working, so you need to contact the same manufacturer, so they will replace it to you by a similar one from their own manufacturer. So it's not like open, so you can buy any module from any places and integrate it from any other manufacturer. No, so it's architect is closed, so you cannot, like, give you the example of a desktop PCs. All the desktop PCs are open architect, so you can take it and plug anything on, add on it, and so on. But you have some laptops are closed architect. So if not all laptops, but for example Apple laptops are closed architect, so you cannot replace the component. They don't make it available to replace the component by other than their own manufacturer components. Like, look to the battery of the laptop, for example. You may see that they make it in a way you cannot replace it by a standard battery. They are not standard. Okay, so you need to buy their own battery. So that's basically what we mean by closed architecture. So I'm not sure, maybe now Apple PC, that's what I know about Apple PC, but maybe now Apple PC they have a version on which they start to open some of the architecture. But in general, closed architect means you cannot replace any component except from the company itself. Maybe you can have a copy version of it, maybe Chinese version, illegal version of it, Alright, so you need to make sure, or it has a license from the Apple industry to manufacture those batteries and so on. But in general, closed architect is not standardized, so I cannot find any battery and replace my laptop battery or screen or the keyboard or etc. Okay, so that's basically in the context of PLC is the same. So open architect design allows the system to be connected easily to devices and programs made by other manufacturers, even the interface from outside. In open architect, you can select any sensors and actuators, devices, field devices. But in closed architect, maybe you need to stick with the actuators and sensors made available by the manufacturer itself, because they are not compatible. The interface, input-output interface they made are not compatible with the available actuator and sensor in the market. Maybe they have specific voltage, they choose maybe this kind of things, so they make it, maybe the interface, connection interface is different and you don't have adapter for etc. They make it this way. For example, you can see it in a lot of interfaces that are not standards, are not commonly used. So this interface you can only buy from them, unless if you copy it from other companies in illegal way, or another company that they take license from the manufacturer to produce those elements or those components or those parts. So then easy to be connected easily allows the system to be connected easily to devices and programs made by other manufacturers. Even the program, you can load it and use it, so it's suitable, compatible to different type of program. But enclosed architect is one whose design is proprietary, making it more difficult. More difficult means not impossible at all, but it's more difficult to connect to other systems. As for program architect, as program architect, yeah, you have different type of programs. Does that mean you have different languages? We will see that later, but in general you have the same language in which you program the PLC with minor differences. We may talk about it later. Okay, so that's open and closed architect. Hope is clear. Explain the difference between open and proprietary architect, or open or closed architect. You have it here, so now you can answer the question for your homework. Fixed input output. So here what is typical of small PLCs that come in one package. So you see we have fixed input output and modular input output. So what's the difference between fixed input output is typical of small PLCs that come in one package with no separate removable units. As in the case of modular input output, you will see you have separate or removable units, so you can add as many input output, for example, as you wish. But fixed input output, usually it comes for small PLC. You have limited number of input outputs and you cannot add on. So this is basically what it means. So the input section and output section are part of the PLC itself. You cannot add on. Okay. Later on, in different chapters, we'll see the wiring of the output field, of the input fields devices and output fields devices, basically sensors and actuators, light, etc. So wiring connection to the PLC, we will see it in later. But now we are still in talking about the PLC, looking to the PLC, understanding it. So that's fixed input output architect. You may find some PLC use fixed input output, means you cannot add on. So they come with limited number of input and outputs. However, modular input output, so you can see here, you have a what we call stack or rack. You have a rack on which you can plug in, add more slots for more input devices, more output devices, and that's modular input output. Is divided by compartments into which separate modules can be plugged. This feature greatly increases your options and the unit's flexibility. And it looks like that. So you have rack with slots. You can add as many input and output modules as you wish. Okay, in some of them you have a rack in which you can, okay, the power supply alone, the processor alone, etc. The input output module alone, and you have spaces, so you can add even more slots for more input output, etc. Or even increase the CPU capability, etc. So just you take them as a modules. But now focusing about modular input output. So now we understand that we have two types of input output. One in which when the PLC came in one package, so you cannot add limited input, and other you can add on it. So then, like how it looks in this photo, so you can add more slots in your rack. Describe how the input output modules connect to the processor in a modular type PLC configuration. So it's a question, and actually I'm putting the answer for you. Describe how the input output modules connect to the processor in a modular type PLC configuration. Well, maybe you need to do your own search to answer it, or hear back, play video back when I was talking in a while in previous slide. So the input output modules plug into rack. I was talking about rack, right? When a module is slid into the rack, it makes a connection with a series of contacts called the backplane. Backplane is the series of contacts, so that's how they are connected. So it's not like in air, just you put in the rack. No, you have a backplane in your rack in which the input output module will be connected. The PLC processor is also connected to the backplane and therefore can communicate with all modules in the rack. Alright, so basically that's it about. We didn't talk explicitly about it, so now you understand, and this will be your questions. To be able to answer it correctly, you need to come here or do your own search for your homework. Okay. The power supply. So now talking about the power supply. Also it could be plug-in, as the processor itself could be plug-in on the rack, and input output slot you can slide it into the rack, and all of them they are connected by the backplane. Okay. So the power supply provides DC power to all modules that plug into the rack. That's the power supply. Of course, power supply provides DC power to all modules that plug into the rack. For large PLC systems, this power supply doesn't normally supply power to the field devices. If you have a large PLC system, you expect to have large number of field devices, means large number of input and output devices, large number of sensors and actuators. So then those sensors and actuators are not powered by this power supply, powered by an external power supply. And you'll see in the distributed network, maybe you put your input output devices not close to the CPU, you wire them far from the CPU itself, close to the machine you are controlling, or not necessary wiring by even wireless communication. Okay, so you have the communication mode. So then, yes, so that's what I'm saying, that in, for example, of fixed small PLC or few number of input output devices, so then you could power them directly from the power supply. But in general, For large system, you don't power the field devices from your power supply. Okay. So now talking about input output, we saw the CPU, we saw the power supply. What about the CPU or the processor? It consists of a microprocessor for implementing the logic and controlling the communications among the modules. Of course, it's a microprocessor for implementing the logic and controlling the communications among the modules, among the input-output modules, etc. The processor requires memory, of course, for storing the results of the logical operations performed by the microprocessor, as well as the operating system for storing the operating system and the PLC program, of course. So we need a memory for the CPU to work properly. Okay, so associated with memory, and those are the major parts of a PLC. CPU is a microprocessor. Okay. Now we understand the major part of a PLC in a bit more details. What about the execution of the program? Well, that's in general the execution of the program happens this way. We read the input, we execute the program, and we update our outputs. And the unit will repeat it continuously. Each cycle we call it a scan. So understand what scan means. Scans, it's a cycle, and this cycle is repeated as a loop, so it's repeated continuously. Always we are reading the input, and it's very fast. Okay, so we are reading the input, executing the program, and update outputs. Of course, intermediary you have diagnostics and communication. What we mean by diagnostics, like when you run your code, when they execute the program, you check for errors and so on. If there are any errors and in your connection, it happens, or it was happened in the past, this kind of diagnostics. So it will check it before updating the outputs. And there is some communication internally between data and memory, so you have this kind of, but basically read input, execute program, update output. Start with the CPU reading the status of all input, concludes with the updating of all outputs. This is what we call scan. Okay. Now, talking about the input-output system forms the interface by which field devices are connected. So, the input-output modules of the PLC serve as the interface. They are interfacing with the external world, interfacing with the field devices, with the sensors and actuators. As input devices, you can name a few as push buttons, limit switches, push button, limit switches, maybe sensors, type of sensor, ultrasonic sensor, or etc. But you could have lot of inputs. Okay. We again later on later on in the course, in different chapters, we'll talking about wiring, how we wire inputs and output devices to PLC. So now we don't talk about, but just telling you now, you need to understand that the input output modules are the interface with the external world, with the field devices. Okay. And of course input and output. Okay, output devices for now, let's name motor starter, valves, indicator light, etc. And those are connected to the output module. So again later on we'll see the connection of the input output, how we connect input output devices to PLC. And also in even more in advanced chapters we'll talk about the type of input devices and output devices. we use for a PLC. Okay, so now we will see them in details, all the type of output devices and input devices. And we cannot also name all of them, even in that chapter, because you may have different even and more inputs and output devices. But the standards that they are used in industries. We will look at the inputs, output. That's in a chapter or a part of a chapter called sensors and actuators. Okay. What else we need to know about? We need to know about a programming device. Programming device is used to enter the desired program into the memory of the processor. That's a programming device. In the past, we had what we called handheld programming device. It's a device that you hold on hand by hand, in which you program your PLC and you wire it to the PLC and you load the program. Okay, so you have small screen, it gives you some order. So you do your program using this manually by hand. So now it's most commonly because PC are portable and so on. So it's most commonly to use a PC to program it, and because programming becomes more easy because you can have a touch screen or using your mouse and drag interface and use. That's a program written, if you can see, for example. Okay, and here, etc. So you have a block and you have some output, maybe here, etc. Okay, so this is a program written, is trying to, etc. So then you just upload it. So then a programming device as handheld programming device or the PC itself. The program is entered using the relay ladder diagram, if you call it ladder diagram, LD, or it's a programming language. We'll talk about programming language later on, of course. But now talking about the programming device. It could be PC, it could be handheld device. Personal computer we're talking about is of course is able to display more logic on the screen with simplifying interpretation of the program. So it's the most commonly used programming device. Of course, the PLC now, the PC now, is the most commonly used programming device. What are the two most common types of PLC programming devices? You have the answer, so you can answer your homework. Now we introduced the PLC architect. We're starting to understand them. Let's talk about the program itself. And a program is what? A program is a series of instructions that directs the PLC to execute actions. Of course, that's the definition of a program: series of instructions that directs the PLC to execute actions. Series of instructions, those are the instructions. Okay, all of those are instructions. We'll understand them later. Basically, whatever looks like that, or at the end in here, usually we have the output. This is connected to the output pins or the output interface. They have number, and usually those are connected to the input field, devices. So you read from the input field devices like how, and you write to the output field devices like how. And in advanced chapter you will see that it's not necessary to be connected to digital input outputs. You could connect to analog input outputs. Relay ladder logic is the standard programming language. Is based on electromagnetic relay control. So relay ladder logic, or we call it ladder diagram, or sometimes we abbreviate it by ladder, like LA and D, ladder diagram, ladder logic, so LL if you wish, but the common abbreviation is ladder diagram, LD or LAD. That's it. On which the line we call it rank. So you are line 1, line 2 means rank 1, rank 2, etc. And those are, we call it branch. So now you understand branch, ranks, and instructions. And it's a standard programming language. There is almost no difference from all manufacturers. It is almost the same. So you will note the ladder program is almost the same, and it's standardized to a large extent. Slight difference which you can note it, for example, in some software, some company they write it this way, other company they write it this way. So then it is the same, okay? So it's not really, for example, the output, some of them they call some of the output, it's not like this. You have a different output called reset and set. If you want to use reset and set, maybe in another company they call them latch and unlatch. Alright, so this is small differences, but in general it's standardized. The small differences are not really differences. Even so, we appreciate if we have all of them standardized, because the standardization process, as I may explain to you later on outside the course context, maybe I explain to you about it. They are um, they are starting to standardize it late. So then the company already started to launch program and develop and so on. And later on, when started to standardize things, they still have some minor differences between them. But now any new companies, any manufacturers of PLCs going to the markets, they directly follow the standardization. Standardization is established like not so far ago. We may talk about it as a general information later at the end of the chapter, if you wish. Explain the terms program and programming language as they apply to a PLC. Program and programming language. Explain it. What is the standard programming language used with PLC? What is the standard programming language used for a PLC? So then you can answer the question by referring to the slide. Explain the main function of each of the following major component of a PLC. CPU, input-output modules, programming device, power supply module. All of them, we saw them in previous slides. So explain the main function of each of those major components. CPU, input-output, programming device, and power supply, which we saw them. The programmable controller operates in real time. What does this mean in your opinion? Okay, I'm giving you the answer. Operates in real time. The PLC programmable controller operates in real time. It means that a PLC operates, it means that an event taking place in the field, will result in an operation or output taking place directly. If an event happens on the field, maybe a bottle of water pass the sensor, the box is full, any event happen, so your sensor is reacting immediately, will result in an operation taking place at the output. Like, okay, the box is full now, so then I move my conveyor, right? Then another box reach my sensor, so I stop the conveyor. Then I start opening my valve, so I fill my water bottle in water, my plastic bottle in water until it's full. When it's full, the sensor will react, so I stop the valve and I move my conveyor. Okay, and this could happen in very quick way because the PLC is very fast in response. Alright, so that's what we mean by real time. Principles of operation. Well, the principles of operation, we'll be discussing it in our interactive session. So maybe I'm not going to spend time talking about it now. In our interactive session, we will take this example and explain it. Alright, so we'll be seeing all of those. Even modifying the operation also will be in our interactive session. Here is a question for you as an exercise in your homework. Compare the method by which the process control operation is changed in a relay-based system to the method used for a PLC-based system. To be able to answer this question, you need to be live with me in the interactive session. Here the question is answered, but let's see. Relay system is changed by changing the wiring. PLC system is changed by changing the program. So if you want to change a relay system functionality, relay system operation, so you need to change the wiring. But in a PLC, just changing the program, and we understand it's much more easy to change the program than disconnect the wire and connect them again. And you may have some disconnection errors, you cannot test and troubleshoot, etc. So that's the answer. It's also part of your homework, which I didn't put the answer in the homework. So if you're lucky and you show the video, so you're able to answer it correctly. Or if you was with us in the live session. Now PLCs versus computers. What's the difference between PLCs? They have the same architecture. So is there any differences, commonality, etc.? The architecture of PLC is basically the same as that of personal computer. Unlike PCs, unlike personal computers, the PLC is designed to operate in the industrial environment. Here is I reveal the secret. Is designed, however, to operate in the industrial environment with a wide ranges of ambient temperature and humidity. Maybe in industry context, you are not like in a clean room, everything is controlled and so on. So you have a humidity, you have a range of ambient temperatures sometimes, and so on. So this all, so it's designed to operate safely in a wide range of ambient temperatures and humidity. Okay, so it's robust. A properly designed PLC installation is not as affected by the electrical noise inherent in most of industrial locations. So now we understand we have the temperatures, we have the humidity, and here in addition you have the electrical noise. Is not affected by the electrical noise if the PLC installation was properly designed. So it's not going to be affected by the electrical noise. And this is also one point you should, by comparing it, you should consider when comparing to a personal computer. Also, unlike the personal computer, the PLC is programmed in relay ladder logic, or this is what we call ladder again diagram, or abbreviated by LD or LAD. So programmed in relay ladder logic or other easily learned languages. We'll see some of them, but the focus of this course is a ladder logic. Of course, we'll see others. Okay, mainly we'll focus actually on two languages: ladder logic and function block. Those are function block. Those are the most commonly used. Sometimes you need function block. So Ladder logic are those operation, etc. And function block, you can see a block T on, timer on, etc. Okay, those are the main two languages, but we will introduce other languages briefly. The PLC comes with its program language built into its memory and has no permanently attached keyboard, CD drive or monitor. When you have the PLC, you download to the memory the program, or it could be downloaded for you from the company itself, which made the application for you. Then it's possible, but of course you can yourself change the program and change the application. Comes with this program language built into its memory and has no permanently attached keyboard, CD drive or monitor. Right, so only you attach the monitor or the PC in general to download the program in case, but otherwise it's not permanently attached, the LCD, the monitor or CD drive, etc. as a computer. Computers are complex computing machines capable of executing several programs or tasks simultaneously and in any order. Multitask machine, of course. PLCs execute a single program in an orderly and sequential fashion from first to last instruction. That's how PLC execute a single program, only a single program, from first to last instruction. And like you have monitor inputs, execute program, change output, then monitor, okay, check the inputs, execute control programs and update the outputs. That's how a PLC work for a single program, just has a single program, not multitask system. What other comparison we can find? PLC control systems have been designed to be easily installed and maintained. Designed to be easily installed and maintained. So now if you have a new application, you can easily connect it, connect sensor actuator. You will see when we do wiring how easy is the connection of sensor and actuator compared to relay system also. So then it is very easy thanks to the interface was easily installed, and the maintenance is very easy. You can have an indicator telling you it's faulty, battery problem, you need to change if it was not powered by a power supply, maybe it was outside or not connected. It could be possible with battery, in addition to its inherent battery for the CPU which keep running, so which has, this is always running. If you disconnect it, the battery works, and faulty, it tell you it's faulty indication, it's currently running, and so on. Also you have fuse, and you have indicator status for the output and the input. Alright, so this is for maintenance. You have fuse for protection, and you have indicator light, tell you this output is active, this output is not, this output is connected, this not. So status indicator is this output is on, is off, basically on off. You can see the indicator light on the PLC itself. In addition, you can have a later on at the end of this course we will look a bit about human machine interface. Troubleshooting is simplified by the use of fault indicators, and messaging displayed on the programmer's screen. And if it's connected to a PC, maybe, and you do the program is in simulation, so it tells you the errors and you can modify them. Even it's a human machine interface, you can program the interface in a way it tells you if you have errors, or it gives you all this indicator light and so on. You can program them in a virtual environment in your screen, not physically. You can see the light, you are far from them with your tablet, for example, on which you are seeing via human machine interface the status of the output input, or even you can control inputs and outputs. Okay, input output modules for connecting the field devices are easily connected and replaced. Input output modules themselves are easy connected and replaced, but also the input output devices, the fields themselves, are easily connected to the PLC. Okay. Now I want to, based on what we explained, compare the PLC and PC with regard to physical hardware differences, operating environment, method of programming, execution of program. So based on what we explained in a while. Okay, luckily I'm giving you the answer you can look at, but in your homework you don't have the answer. Physical hardware differences. Unlike personal computers, the PLC comes with its program language built into its memory. That's the PLC built into its memory, or you can program and download to the memory, and has no permanently attached keyboard, CD drive, or monitor. That's the physical hardware differences between both. In terms of operating environment, unlike personal computer, PLC are designed to operate with wide range of ambient temperature and humidity. Also noiseless electrical noise isolation. Method of programming. Unlike personal computer, PLC is programmed in a relay ladder logic or other easily learned languages. Execution of program. PLCs execute a single program in a sequential order, while computers execute several programs or several tasks simultaneously in any order. Okay, that's multitask architect. So you have software associated with PLC, but written and run on a personal computer, falls into two categories, two broad categories, if you wish. We will say it this how. So again, software associated with PLC, but they are written, pay attention to it, written and run on a personal computer, and that's what we usually have. So the software are written and run on a personal computer, then we download, after simulation, we download them into the PLC. We don't use anymore the handheld device, so all on a PC. So they fall into two broad categories. First category is PLC software that allows the user to program and document. I'll put it into like this type of sentence. So PLC software gives the user the tools to write a PLC program and document or explain the program in as much detail as is necessary. So that's the first category. The first type of software is PLC software gives the user the tool to write a PLC program. The software gives you the tool to drag, click, right-click, name, address, etc. So it gives you the tools to write a PLC program and also document or explain the program in a much detail as necessary, so you can comment on your program. That's the first category. So the PLC software, which we basically use to write the program and comment on it. Alright. And the second category of software is they are written and run on a personal PC is the human machine interface software. And this software allows the user to monitor and control the process. So this is a panel, a touch screen if you wish. It's here. You can see that's a panel, touch screen panel, on which you loaded a program and this program you loaded it to this touch screen panel, and this program which you see here, the program here, is written using a software. So that's the second type of software, which we will be seeing it at the end of this course. At the end of this course, we'll show a different software, a more advanced software, in which it will give you the ability to write a human machine interface and load it into the touch screen, which is connected in turn to the PLC. So that's the second type of software. So software to write the program and comment it, and another software which allow you to use a monitor and control the process. So that's a monitor. Okay, it enables the user to view a process or a graphical representation of a process on a monitor. Determine how the system is running, trans value, and receive alarm conditions. So basically it's an interface with the machine, right? So what two categories of software written and run on a PC are used in conjunction with PLC? So this question you need to answer in your homework, but here I'm giving you the answer for your reference. So software that allows the user to write and document a PLC program. Software that allows the user to monitor and control a PLC program. So this is the first type, allows the user to write and document a PLC, comment on a PLC program. Second type of software allows the user to monitor. So you have a LCD screen to monitor and control a PLC program. You can also control your inputs, on, off, etc. Turn something on, turn something off from your monitor. So then from your screen. So this is the second type of software. All right. So now what is PAC? So PAC, or programmable automation controllers, combine PLC ruggedness with PC functionality. Using PACs, you can build advanced systems incorporating software capabilities such as advanced control, communication, data logging, and signal processing with rugged hardware performing logic, motion, process control, and vision. Okay, so combine ruggedness of PLC with PC functionality. That's PAC. Well, so how to describe PAC actually? Well, PAC, it's an advanced PLC. Like it has more memory capability, more input-output interface, modular. Well, for me, like PAC, it's just a commercial name. You can have advanced PLC, depends on the application. It's an advanced PLC. It has more functionality, more memory, more input-output. So now you know the PLC, you have modular, you can increase the input-output, but PAC can go unlimited, like thousands or so of input-outputs. So then it has more memory capability for vision. But basically, because PLC keep advanced and they put on it modular and so on, so there is no big differences. Well, of course, if you want to compare small packed one PLC with a PAC, yes, but if you look at the opportunity that you have and the available PLC available in the market, like modular PLC and so on, you'll find minor differences, or even there is no differences. So PAC is advanced PLC. Just be aware about it. Like depends on your application. You can choose PAC or simple PLC or more advanced PLC and so on. Right. What is programmable automation controller? You need to define it from the previous slide. This is also one exercise. A PAC is a device that combines PLC style control and ruggedness with PC functionality. well, that's what's defined in the textbook, but I'm telling you in practice it's an advanced PLC. It has advanced capabilities, so there is no, it's like kind of you can say it's a commercial name, nothing more. Okay, so now we will see PLC size and applications. um, in here, the criteria used in categorizing PLCs include functionality, number of inputs and outputs, cost, and physical size. Okay, so when you want to select a PLC, the characteristic of PLCs, you have a lot of characteristics, but usually in categorizing, differentiating between PLC and another, which one you want to select, we look mainly at four things: functionality, we will see it, number of inputs and outputs, cost, and physical size. So on the next coming slide, we'll be seeing one will be seeing number of input output. Second, we'll be looking to functionality. What's the functionality of the PLC? And third, we'll be looking to the physical size. We are not going to look to the physical size, actually. We'll be looking to the memory size, the capacity, memory size. So on selecting a PLC, I'll be going with you in the few coming slides on looking to the number of input and outputs you need, the functionality that you want from your PLC, and the capacity or memory size of your PLC. We are not going to look to the cost, but cost, of course, it's a factor in which you categorizing PLCs, like cheap, expensive, it's good price, etc. Physical size of it, like the area that occupy. Okay, we are not going to look to the physical size, however we are interested to look more on the memory size. Okay, those are the three main things we'll be looking at. Cost we are not going to look at in this chapter. So let's start with the input output. The input output count, how many input output, is the most important size factor. Why? Because in general, well, the nano is the smallest size. So nano PLC, it's usually with less than 15 input output. Okay, micro PLC is usually between 15 and 1 to 8 input output. Medium PLC types between 120 and 512 input output, and large type are over 512 input output points. Matching the PLC with the application is a key factor in the selection process. You need to match your PLC with the application. How many input output you want to use? Do you want is it enough for you nano, or you use micro types, or medium, or large types? So that's as for the PLC, how to categorize PLC with respect to the number of inputs and output. I told you the second thing we'll see is the functionality. So there are three major types of PLC applications. Three major applications of a PLC function, if you wish. In that end, we call it function or task or application. That's what I mean by those three. One is the single-ended, second is multitask, and third is control management. What we mean by those three tasks: single-ended application involves one PLC controlling one process. And just you have a PLC controlling one process. This is single-ended application. So mainly maybe nano PLC is enough, micro PLC is enough, not more. Like this one, it looks like a micro PLC, less than 120 inputs out. Multitask PLC application involves one PLC controlling several processes. It's one PLC, but you control several processes, and in that type of task, you must probably need a lot of inputs and output. Adequate input-output capacity is a significant factor in this type of installation. But still, it's a one PLC controlling several processes. Another application of PLC is a control management PLC application. So you have single-ended application, you have multitask application, and the PLC could be in an application which called control management application. Involves one PLC controlling several others. So one PLC, which is this PLC in the schematic, controlling several others PLC and controlling a PC or communicating with a PC. So of course we have the communication, but the master is the PLC. This kind of application requires a large PLC, so require a large PLC, or we call it control management PLC. Okay, control management PLC in general we call it control management PLC. It's a large PLC, large PLC processor. So this PLC, it has a large processor. Why it should have a large processor? Designed to communicate with other PLCs and computer, because it needs to communicate with other PLC and computer, maybe ordering programs to them, gathering data and so on, and taking decisions. This control management PLC, the control management PLC supervises several PLCs, PLC 1, PLC 2, PLC 3, etc. by downloading programs that tell the other PLCs what has to be done, giving orders. Okay, maybe you answered the question. Compare single-ended multitask and control management type of PLC application. We just answered in the slides, so it's part of your homework as well. Okay, answer is given. Single-ended application involves one PLC controlling one process. Multitask application involves one PLC controlling several processes. Control management application involves one PLC controlling several other PLCs. So we saw the input-output is a one important part in categorizing PLC. We saw the functionality is one important part, single-ended multitask and control management. Now the last part of this chapter and the last point is the memory size. The memory size of a PLC is also something we care about, one of the important characteristics of PLC when we want to select one. Is part of PLC that stores data, instructions, and control programs. And stores data, the instruction, and the control. Memory size is usually expressed in K values, and like 1K, 6K, 12K, so on. For example, you can select a PLC with 6K memory size, or with 12K memory size, or with 1K memory size, etc. The measurement kilo, abbreviated K, normally refers to 1000 units, which we all know about. But when dealing with computer, especially now for mechanical students who are taking this course, when dealing with computer or dealing with a PLC memory, however, the 1K doesn't mean 1000, means 1024, 1024. 1K equal to 1024. Later on, we have a chapter, the third chapter actually is about system digital numbering and coding. We will be briefly introducing them, but it's not like a fundamental part of your course. So I'm supposing like we have mechanical engineering students, so it's like kind of refreshment or will be as a short chapter talking in brief as a general culture about coding and system numbering and numbering systems, rather than something really fundamental to the course. We need to have this culture information about computer, about system numbering. Okay, we'll be giving in chapter 3 anyway. So 1K is 1024 because this measurement is based on the binary number system. So 2 to the power 10. Okay, so 2 to the power 10 is 1024. So 1K is 2 to the power 10. It is, that's what we mean by 1K. And 10 is like 10 bits. We call 10 bits 3 up to 10. 1, 2, 3, 10 bits. And each bit it will store high voltage, low voltage, 0, 1, 0, 1, 0, 1. And this 10 bit, it will permit you a capacity of 2 to the power 10, which is 10 to the power 10 to 4, 1024. Anyway, just what you need to know is that 1K is 1024 actually, is not 1000. Just the point. Depending on memory type, 1K can mean 10 to 4 bits, but could means 10 to 4 bytes. So they tell you it is 1K byte or 1K bit, like let's say 10 to 4 bits or 10 to 4 bytes or 10 to 4 words. What's the difference between bit, bytes and word? Simply, bit is just a bit, byte is just single unit. When we say byte, byte is, so 1 byte, that's what you need to know, equal 8 bits. So each 8 bits, they call them byte. Byte is 8 bits. Each 8 bits, they call them 1 byte. That's in computer engineering, you should know this type of conversion. 1 byte equal 8 bit, and 1K is 10 to 4. 1K. So then now when you say megabyte, you understand kilobyte. So I understand what you mean by kilobyte now. If I tell you 1 kilobyte capacity, so you understand 1 kilo is 10 to 4 and byte is 8 bits. 8 bits. So in total, you know how many bits you will be having as a capacity to store data. Alright. So 1 byte is 8 bits. Maybe I tell you, you find a PLC saying 1 kilo word, not 1 kilobyte. It's more familiar to be represented in byte, and 1 byte is 8 bit. But you may find some representation saying word. And here in computer engineering, you need to know that 1 word is simply 16 bits, or it is 2 bytes. 2 bytes. Okay, that's everything. So let's see what's here. The amount of memory required depends on what? Of course, depends on the number of input output. So when you select a PLC with some amount of memory, think about your number of input outputs you have, size of control program, the data collecting requirement, how much data you want to collect. This is so you can, for example, control management PLC or supervisor PLC, it needs more memory because collecting more data and giving a lot of programs. So then supervisory functions required. Is there any supervisory function required? If that's the case, then maybe probably you need a high amount of memory. So future expansion, maybe you should plan, you need to have future expansion, increase the number of input output, so then have a high memory. This is from inside how it looks like. Here is the memory, here is some integrated circuit, and here is the microprocessor. Here are the backplane connectors to the rack, and here is battery backup, usually it's from inside. yeah, just our main focus just the memory. I want to show you from inside the memory itself. Okay, that's it for this chapter. List 5 factors, part of your homework, affecting the memory size needed for a particular PLC installation. Well, I just cited them here. 1, 2, 3, 4, 5 factors. Okay, those are the factors that affecting, so then you can solve the question. Alright. Okay, what's the memory capacity expressed in bits? They tell you what's the memory capacity expressed in bits for a PLC that uses 16-bit words. 16-bit words, 16-bit words, like using one word. One word is 16-bit. One word is 16 bits. Using 16 bits word and has an 8K word capacity. Its capacity of this PLC, you read in the datasheet, the capacity of it is 8K word. What is its capacity in bit? 8K is 8 times 10 to 4, right? Because K is 10 to 4. And word is 16 bits. So then you can find its capacity in bits, how much it is. Alright, that's it for this chapter.